Okay, 8.5 in your textbooks, page 461. We're learning about volumes of pyramids and cones. So the goal is to investigate formulas for the volume of pyramids and cones. So the first question tells us that we have an oil lamp. So if you can imagine, you remember what an oil lamp is, but basically it's a lamp. So it looks like kind of like this. And there's a reservoir where you pour oil in. Okay, so we're putting oil into it, and it holds oil within the lamp itself. Okay, and the oil actually comes in big bottles. So there's a bottle, let's say like this, of oil. Okay, the question wants to know how many lamps can we fill up with one bottle of oil. And it tells us the oil comes in 750 milliliter bottles. So the way we can figure that out is if we can get the volume of the lamp, the volume the lamp contains, then we can take our oil volume divided by the volume that goes in the lamp, and we'll figure out the number of lamps we can fill. You guys understand that?
Yes.
Because that's important that you understand where you take a bigger number, you divide it by the little number, and then that's how you find out how many of the little number goes into the bigger number. In this case, volumes, how many units of measure. Okay, so that concept is important because we use it several times within this unit. So it tells us that the lamp has a reservoir with a regular pentagonal base with a height of 8.1 centimeters. Okay, so what that means is a pentagonal we know has 1, 2, 3, 4, 5 sides. And when it says regular, that means that each one of those sides is the same. Okay, the side lengths are the same. And then it says that it has a height of 8.1. Now notice there's no 8.1 dimension on this base. Okay, because we're referring to the height, which would be in this direction. Okay, if you imagine this as being the base of our oil can, it's sitting on top of the blackboard, the volume or the height would be in this direction. Okay, so these dimensions are not in reference to that 8.1. We haven't used that yet. Now, just like we would with a traditional cylinder, in order to calculate the volume, so with a cylinder, we calculate the area of the base and then we multiply it by the height. So there's your height and here's your area of the circle. So just like for the area of a cylinder we should all know is pi r squared, which is the area of the circle on the bottom, times the height. Okay, does everybody know that? Everyone's familiar with that?
Yeah, sure.
So that
might be the surface area.
No, sorry, yes, that's the surface area of the cylinder. Yeah. Sorry. Not the surface area. My bad. That's the volume of the cylinder. Okay? Yeah, my mistake. Thanks, Michael. So that gives us the volume of the cylinder. You guys should be familiar with that because we're using that same concept when we start talking about pentagonal base pyramids. We need to find the area of the pyramid base and then multiply that by the height. Okay? The only difference in what we're going to talk about in a minute is when it's not a cylinder, when it doesn't come straight up but it comes up to a point. So in other words, it comes up like this. We don't multiply it by the height, we multiply it by 1/3 times that height. Okay, obviously because it's now taking up less volume, it's taking up a third at the top. Okay, we're going to talk about that in a second, so let's move on with the problem. So it says oil comes in 750 milliliter bottles. How many times can you fill the reservoir with one bottle? So in other words, it's asking what's the volume of the reservoir? If we can find the volume of the reservoir and plug that and divide it by this number, we can figure out how many times the lamp can be filled. So to do that, first we need to find the area of the pentagon. So here's my pentagon. What I've done here with dashed lines is I've divided the pentagon up into 5 triangles. 1, 2, 3, 4, 5. Each one of those triangles, because it's a regular pentagon, has the same base length. Okay? So what happens then if we're moving to the very center of this pentagon, we know that all of these lengths are the same. So basically, all 5 triangles are the same, have the same area. Okay, so if we can figure out the area of one triangle, we can figure out the area of the base by multiplying it by 5. All right, so these dimensions are given. We're given a height of 4 and a base of 5.8. So we can figure out the area of the pentagon by taking 5 and multiplying it by the area of one of these triangles. Any questions there? All right, so once we do that, we figure out that the area of this pentagon shape is 58 centimeters squared. Now we need to find the volume, so we need to multiply that by the height. All right, the height is given as 8.1. So the only trick here then is to recognize that when we go from this shape, which is called a prism, to a pyramid shape, we need to multiply it by 1/3. Okay, so same thing if we were going from a cylinder shape to a cone shape, you're going to take the formula for volume of a cylinder, which I mentioned was volume is pi r squared times h, and it's actually going to be 1/3 pi r squared times h. Okay, so you guys should be familiar with this formula. Today we're learning about this formula. Okay, so whether it be a pyramid-based prism or a cone, you're going to multiply the volume by 1/3. Any questions there? Okay, so then we can calculate the volume of our pyramid. 1/3 times the area of the base. I'm going to add a little b there, which we calculated was 58 times the given value of the height. Okay, so we figure out our volume of our pyramid is 156. Now, to convert centimeters cubed to milliliters, we should all know, we know that 1 centimeter cubed is 1 milliliter. Okay, that's just a basic rule in science that we know. So 156 centimeters cubed is the same as 156.6 milliliters. Okay, those units can change, and that's based on the density of water. All right. So now we take 750, we divide it by 156.6, and we can see that we can fill 4.8 lamps, or 4 full oil lamps. Any questions there? So therefore, we can fill 4 full lamps. Oil lamps. All right? Example number 2. So in this case, it tells us that we have a conical paper cup. So this is like those paper cups you get at one of those water bottles in an office. And then we have a cylinder here. So it's asking how many of these paper cups, or how much volume can we put into the cylinder. So it's pretty much the same problem. We need to calculate the volume of the cylinder, and we need to calculate the volume of the cone. Once we have those two values, we take our larger value, the cylinder, and we divide it by our smaller value, and then we'll figure out how many cones can fit into that cylinder. So how many cones fit in the cylinder? Find the volume of both, divide cylinder volume by cone volume. Okay, so those are the steps we're going to take. So we know the formula now for the volume of a cone. I mentioned it. For a cylinder, it's pi r squared times h. For a cone, it's 1/3 pi r squared times h. So these values are given. We know the radius is 4. We know the height is 10. So we can just plug in those two values, and we get our volume for the cone. Again, this would be centimeters cubed, or 167.55 milliliters. Okay? Same thing. Likewise, we do the same for the cylinder. This time our radius is actually again 4. Remember, radius is this distance. If they give you this distance, the diameter, you have to divide it by 2 before you plug it in for r. Okay? You understand that?
Can't you use the diameter in your equation?
No, for these equations we're going to use radius. Okay? Yeah.
Sir, if you want to find, for example, going back to example 1, if you want to find the volume of the pentagonal prism, you just don't divide by 3, right?
If you want to find the volume of this one,
Yeah, you just
Yes.
don't divide
you
by
just
3.
multiply by the height. You're taking that area and you're just multiplying it up.
Yeah.
Whereas if it's a pyramid, you have to divide by 3. Okay? All right, so we're finding the volume of the cylinder, pi r squared times height. So again, our height here is given as 20. Our radius is 4, so we get 1,005. To figure out the number of cones in the cylinder, we take the volume of the cylinder, divide it by the volume of the cone, and we get a nice round even number of 6. Okay? Again, a word problem, you finish this off with a sentence. 6 amounts of the cone can actually fit into the cylinder size. All right? So finally, the summary. There's our formula for volume of a pyramid. Here's our formula for volume of a cone. Most of these problems, it's simply a matter of identifying the variables and plugging them in. The only trick might be to find this area of the pyramid. You need to divide that particular pyramid, however many sides it has, into equilateral triangles or equal triangles, and then multiply it by the number of triangles to figure out the area of the base. Any questions? Okay, pretty straightforward. That's the end of the lesson.